All right, in this page of the notes, we're going to add and subtract polynomials, but before we do that, I want to talk about what it means for a set of numbers to be closed under an operation. So we're going to look at the set of integers, and we can use capital Z with an extra line for the set of integers, but let's first of all review what the set of integers looks like. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, on it goes forever. Remember, those 3 dots mean it goes forever. The list goes forever. And it's also the negatives of all those. So I've listed, well, I couldn't possibly list all of them. Those 3 dots means it goes on forever. But that's our set of integers. And that set is closed under addition, because if we add 2 integers, we get another integer. That set is closed under subtraction. If we subtract an integer from an integer, we get another integer. If we multiply 2 integers, we get an integer. So the set of integers is closed under adding, subtracting, and multiplying, right? We are going to talk about polynomials and how the set of polynomials is closed under addition and also subtraction. And next time we'll see that it's closed under multiplication. So what that means is the sum of 2 polynomials is a polynomial. Remember, sum means add, right? And difference means you're subtracting. So if we add 2 polynomials, we get a polynomial. If we subtract a polynomial from a polynomial, we get another polynomial. Okay, so to add polynomials, you guys actually probably did this last year. If you add 2 polynomials, you add like terms or combine like terms. We're going to do this vertically. We're also going to do it horizontally. I'm going to show you both formats. So the first one, we're going to do a vertical format. It helps to have them in standard form. So we're going to take the second one, which is not in standard form, and we're going to change its order just a little bit. And then, as I write the polynomials down, one below the other, I'm going to align them vertically. Now make sure if you are missing any powers of x that you leave a little space. We've got x cubed, x squared, x to the first, and for the second one that we're adding to it, we have x cubed plus 2x squared. Notice how we're lining them up according to powers of x because those are the like terms. The minus 1 is not going to line up underneath the x because they're not like each other. One of them has a variable and one doesn't. Remember, to be like terms, the variables have to be the same and the powers have to be the same. So now we're going to add. There's a 1 in front of the x cubed, and to add those like terms, we just add the coefficients. 2 plus 1 is 3. Add the coefficients. So we get 3x to the third. Negative 5 plus 2 is negative 3, so we get negative 3x squared. 1x, well, there aren't any other to add with it, so we just get a plus x, and then the minus 1, and we're done. Okay, that's how that works. The horizontal format, where I'm going to write down the 2 polynomials. We have 3x squared plus x minus 6, and I'm going to add to that x squared plus 4x plus 10. Okay, so I'm going to get rid of the parentheses. 3x squared plus x minus 6 plus x squared plus 4x plus 10. The parentheses are just grouping. They're really not doing anything else. So we can reorder things, and I'm going to reorder them so that the like terms are right next to each other. We get 3x squared plus x squared. You can group them with parentheses if you want to. Plus x plus 4x minus 6 and plus 10. Don't lose anybody. So there's my 3x squared and my plus x squared, my x and my 4x, my minus 6 and my 10. Okay. Combining like terms, they're right there together. 3x squared plus x squared. 3 plus 1 is 4. Remember, combine them by adding the coefficients. A 1x and a 4x. 1 plus 4 is 5. So we get 5x. And then negative 6 and 10 add up to 4. And we are done. Well, let's talk about how to subtract. Subtracting is adding the opposite, and that's the way we're going to do this. So to find the opposite of a polynomial, we multiply each of the terms by -1. So in the vertical format, we'll going to do 4n squared, and we'll leave a little space for the missing n to the first power. So there's my plus 5. And then I'm going to subtract. And people make a lot of mistakes with subtracting. So what we're going to do is we're going to change the signs and we're going to add. So we have 4n squared plus 5. We're going to distribute the negative 1, or the negative sign. Negative and negative make positive, so that negative double negative makes a positive 2n squared. And then the negative, when I distribute it to the 2n, and then the negative when I distribute it to the negative 4, and then we're going to add them up. Okay? So we change the signs and we add. 4n squared plus 2n squared is 6n squared. We have nothing to combine with the negative 2n. And then we have a plus 9, and we are done. All right, we're going to do the horizontal format with the second example. I'm going to rewrite the problem 4x squared minus 3x plus 5, subtracting 3x squared minus x minus 8. So I'm going to remove the first parentheses. They're just grouping the three terms together. But the second set of parentheses, I have to distribute the negatives. Like there's a negative 1 sitting there, and I have to multiply everything inside by negative 1. So negative 1 times 3x squared is negative 3x squared. Negative 1 times negative x, that's this one right here. Negative times negative is positive. Multiplying by 1 doesn't change values. Negative 1 times negative 8 is positive 8. And then we'll move things around a little bit so the like terms are right next to each other. There's my 4x squared and my negative 3x squared. There's my minus 3x and my plus x. And then a plus 5 and a plus 8. Make sure you didn't lose anybody. 4 take away 3 is 1. So we have 1x squared, but we'll just write x squared. We have negative 3x and x, which is negative 2x. So those two, and 5 and 8 add up to 13, and we are done.